Should we do set? Huh? In between sort and set. It's on to you. What should we do? Please conclude, please. So, are you doing set or sort? Huh? Set, Abby? Set, Abby? All right. All right. Let's do set theorem. Let's do set theorem. Now, first things first. When it comes to set, it's a little bit broad in sense that it has to do with much more English, right? It's when you get to the Venn diagram, you do some calculation, a little bit tedious calculation. When it comes to the beginning, more of like you trying to understand what some things means and how to use those things, right? That's like the concept behind set theorem. So let's have this. A set definition, please. I'll take out one by one so you understand it very well. So that Venn diagram, you know, having issue with Venn diagram is because the foundation is not clear, and if it's not clear, you have issue at the back end, right? So let's put on please. Set theorem: a set can be defined as a collection of well-defined items. I said a set can be defined as a collection of well-defined items. The item that contain a set, the items so I said the item that contain a set are called the element of that set. The item that contain a set are called the element of that set. Full stop. How good? Now that's by writing. So look up, please. Let's explain. We said a set is what? A collection of what? Well defined. It should be what? A well defined. If I have a set of 1, 2, 3, 4, 5 until infinity, it's well defined. If I have a set of 2, 0, 1, 16, 50, 30, is it well defined? That's not a set. So a set must be what there? A well defined. If I have a set of all vowel letters, that's what the A, E, that's a well defined order, right? And etc. So a set has to do what? A well defined order. More of like the idea of what? Finite series, sequence and series. Well, that you see that much more later as we proceed. Free, free. All right, all right, all right. Shall I proceed? Now, we have defined set and what it means. So, note this please. Now, why writing set? Please, why writing set? You don't use this round bracket. You don't use square bracket. Rather, use what there? A coney bracket. It's called a coney bracket. Alright, copy that please. A coney bracket, please. So, what doing set? You don't use this bracket. You don't use this one here. What do you use there? A coney bracket. How good please. So set involves the use of a coney bracket. How good? The use what I say now? I said what? Why what there? Using set, right? Or why solving problem set? What do you use there? Use a what? A coney bracket. Full stop please. Usually, come on please. Usually, the elements that contain a set, usually the elements or member that contain a set are called usually the elements or members that what they contain a set are called the elements of that set. Are called what there? The elements of that set. So stop. So that's by the way. Now we said, listen, we said anything you see in a set, that thing are called what the element or member of a set. So I'm saying this: if I have a set A to be equal to AEIOU, that AEIOU are called what they are called element or member of what of that set A. Are we good now? Giving A or giving set Q to be equal to AEIOU, that AI you are called the member of or element of what? Of set Q. Are we good now? At this junction here, let's look at something important called representation of sets. How do we represent sets of sets? So how do we represent sets? Representation of sets. How do we represent sets? I'll go please. There are two ways to represent sets. There are two ways to represent sets. Number one, there we have by listing, and number two, there we have by set builders notation. All right. Number one is called by listing. Number two is called by set builders notation. These two ways are only the possible way of what the of writing sets. So your set from the beginning of the textbook to the end of the textbook, right, or the course outline or whatever they give you, the only way you can represent is what is in these two ways. Now, what do they mean in reality? When you see them in exam or in past class or anywhere, how do you identify by listing and what by set builders? Let's explain that one by one, please. Let's do by listing, please. By listing. All right. By listing. This involve by listing, please. This involve writing out all the elements. This involve writing out all the elements that contain that set. This involves writing out all the elements that were there that contain that set. This involves writing out what all the elements that contain that set. Full stop. So if I say, okay, please, how many bags do you have there? And how many, probably let's say, how many kind of bag do you have there? I might have Gucci bag, I might have other clothes bag, Google bag, things like that. So if I ask you, help me list them out. Okay, I have Google bag, I have iPhone bag, and whatever. So that's by listing. You are mentioning them out, right? So if I give you a set, let's say for instance, giving a set A to be equal to what's it called? Row letters. In by listing form, that gives you what? Okay, put down please, come down. Huh? Mm-hmm. Rooster. And yes, that is same thing as the same language. Same language. I'll go this. Now, type comment first. Okay. Okay, sorry. So when it comes to by listing, is your ability to what read out or list out what you are given. Okay, as example, please. Example. Given a set A to be equal to given a set A, please capital A, please. Given a set A, capital A, to be equal to, write your own in full, to be equal to vowel letters, given a set A, such that set A is what? Is a vowel letter. How good? By listing, it is written as by listing, it is written as, look up this. So I have A to what I give you now? I said what? Given a set A to be what equal to what there? Uh-huh. It's using as truth. But listen now, this is set A to be equal to what? Vowel letter. That gives you your conic bracket. What are vowel letter there? I have A, E, I, O, U. This is what? By listing. I list them out. That's it. This is what? By listing. What do you do there? You list them out. There are some sets you see in a textbook. They'll already give you example one. They'll give you A to be equal to like something like this. 2, 3, 4. This one is what? A representative of sets. In what form? In by listing form. You can see this by listing. Alright. Number two, please. Let's do by set builder, please. This is number one. Number two, by set builders notation. All right, by set builders notation. Okay, now listen. No, we said for this first one here, your ability to mention them one after the other determines what the your by listing concept. So by set builder, you're not listing out, but what you are describing that set. How good? This involves This involves describing a set by proper description. This involves, for this one here, this involves describing a set, in quote please, by proper description. This involves describing a set by proper description. I will go please. So your ability to describe that set leads you to the concept of what? By set builders notation. Now listen to the English. The example I gave you here was what? Giving a set A to be equal to what? The vowel letter by listing. How do you write it? In this form. That same example. So given what the given a set A to be equal to what? The vowel letter by set builder, it is written as set A to be equal to what? The vowel letters. This is it here. I have described it. I didn't write it. I just what? Described it. How good now? So this is set 8 because what the vowel letter in this form. This is what? By listing. It's clear. This is what? By set builders. You can see some things like this. They'll give you sorry, let me even write it. Let me write it proper way. This is not the proper way. So this is the proper way is this place. Look up. So I know how to describe a set. So you say A is equal to X. I'll say this such that X is a vowel letter. How would this? So the idea is this: you have to put S such that X. That's the concept. So I want to describe this vowel letter in by set builder notation. That gives you A no problem equal to X such that X is a what? A vowel letter. Now what is our place? I'll give you one example here now. In by listing. How good? You try to convert it for me to what? By set builders. And by set builders, start with what? X. This line means what? Such that X is a I have described the set. Now look up please. If I say given a set Q, observe this please. Given a set Q to be equal to, observe this flow, 2, 4, 6, 8 for instance. So given a set Q to be this. How good? This is what? By listing. I list them out. Now help me convert this by listing to what? By set builder. What will be please? Who can tell me? So Q equal to what? X, Abi? Such that X is what? Huh? Hold on. Hold on. By set builder, you are describing it. How good? So I said by what? Set builder. What are we doing there? We are describing it. So I'm saying this. I'm giving you a set Q to be equal to what there? 2, 4, 6, 8. Now, if you are describing this, what will it be? What will it be? Huh? Mm-hmm. Why? Just what? Can't you get this right? They have gotten it right. For by listing, you are mentioning them out. So I gave you this question in form of what? By listing. So no problem by listing. I said convert this one now to what? Set builders notation. This is it. A E I O U was in by listing form. So by set builder, I know in science, I have read book before that A E I O U is what? Boolean letter. You are describing it. So you are saying 2 for 6 What comes to mind? You are saying 2 4 6 8. What comes to mind? What comes to mind? Is even number. Even numbers are 2, 4, 6, 8, 10, 12. Those are even numbers. You understand? Or I can give you odd number if I want to. So what is you should identify them. This one is not something I should be explaining again. It's clear that this is what? An even number. Right? So note that if you're having 2, 4, 6, 8, and etc. They are called what the even numbers. So now I'm asking to describe this for me. Said you guys told me that x is q is equal to what? X. Such that x is what? An even number. Which is what? Totally wrong. You told me, fine, I know that 2 for this is what? Even number. I know it's even number. But when I give definition for this, I said what? By what? Proper description. That's not proper description. Because 1000 is even number. Is 1000 here? So why telling me even number? That's not proper description. Uh-huh. Even number less than 10. Makes sense. So I know if I tell you even less than 10 now, you know that you're something 8. So this is what x so that what x is what even number less than 10. So for less than 10, I won't include 10. I'll stop at what 8. That's a proper one, not just even number. Because 25, 1 billion, 1 quadrillion, they are under even numbers, but they're not here. So you have misled me. So this is what x such that x what x is and what even exactly even number less than what 10. All right, this is a what a proper description, please. Now listen, hold on, stop right, hold on. I can describe this way and still be correct. So for by set builder's notation, you can describe it in 2 ways and still be correct. Are we good now? So we said the first one was what? X, such that what? X is what? An even number less than 10 abi. I can still come and say that Q is equal to X such that X is an even number less than or equal to what? 8. If I say less than or equal to 8, it means I am including 8. If I say less than 10, it means that 10 will not be there. If I say less than or equal to 10, it means what? 10 must be included. That's the language. How good now? So these two stuff here are correct. So in quotes, I can write this thing in several ways and still pass the same information. If I go to any class in the world, I told them that okay guys, let's write out even number less than 10. They know what to write. That is 2 for 6 8 and stop there. But if you ask them, let's write out even number less than or equal to 8. You know what I mean. That's what 2 to 8. How good now? So this know the difference, know the idea behind this science. If you see this one that does not have this slash behind it, it means this last one will not be involved. Without less than and equal to, it means that thing must be what there must be involved in the game. How good now? So those are the idea behind set builders notation. How good please? Any question? So I will give you one question now. I will give you a question in form of listing. You give me the set builders notation. Are we ready? Ready? Okay. Um. All right. I gave you QR to be equal to 1, 2, 3, 4, 5, 6. I stopped at 6. right? And I ask you, can you give me this question here in form of by in form of what? Set readers. What will it be? Who can tell what will it be? Uh-huh. Uh-huh. Even number Abi. Odd number Abi. Roman numeral Abi. Roman numeral. Okay? Huh? What will it be? So R is 1, 2, 3, 4, 5, right? Obviously, if I continue this thing, I should have 5, 7. It continue like that, 100, like that. So what do I call that? Huh? Now the thing is this. But what's that thing? What will it be? I can call it natural numbers. What are natural numbers? 1, 2, 3. They are what? They are called natural numbers. There's a different name for it. You can check online. So you need to know those things. You need to not describe those things. 246 is what? Even number. 1, 3, 7. Those are what there? They are odd numbers, right? So you're having 1, 2, 3, 4, 5. These are what there? They are called what there? They are called natural numbers. So I can come and say R is equal to X, such that X is what? A natural number less than what? Less than what? Eh? All right, please. What do you say? R is equal to what? X. So that X is what? Less than. Okay, I agree. The other way. Okay, hold on. You said that R equal to what? X, Abi. So that X is what there? A natural number. A natural. All right. Natural number, right? Less than or equal to what there? 6, Abi. No problem. The other way, please. R equal to X. So that X is a natural number. Less than? Less than? That's correct, please. Less than what there? For less than 7, I'm not including 7. Stop at 6. That's all, please. Copy down. Let's proceed. Copy down. Let's proceed, please. So let's look at types of sets. Hope we're all done with writing that part, please. All right, let me just take this part off. Types of sets. Types of sets. Types of sets. Right? Copy down, please. So by now, you should know how to describe, please. By now, you should know how to describe, right? All right. Um, 1 minute, 1 minute. Vertical, vertical. Wow, you there? It's dark, oh. Someone dark. Let me open this. This one now. All right, so let's go quickly, please, so we can cover up a lot. We might not even we're not get to Venn diagram today, but at least in this class Venn diagram starts because there are two types of Venn diagram, right? We have Venn diagram for two sets and for three sets, right? So we'll explain them one after the other. But let's proceed with it, please. So if you can finish that today, we'll finish that. But if can't, tomorrow, as soon as possible as you can come, we'll finish up sets, right? And partially we move to sword, right? So type of set, please. How good? Number one, please. Number one. Number one. Number one. I have empty set. Um, right? Empty. Am I correct with spelling, please? Empty, right? Sorry. Empty set. All right. Empty set, please. Let's start with what? An empty set. First things first. We have like 9 or 8 like that. But let's do one by one. I have my own order of arrangement of the types because I will arrange it in a way that you understand the pattern, not bringing the last one as first one for you, right? This is the first thing to note, please. Number one, please. Empty set. An empty set is simply a set by the word empty. Nothing is there, right? So an empty set is simply a set that has no element or member. An empty set is simply a set that has what there? No element or member in that set. That's all. An empty set is simply a set. An empty set is simply what there? A set that has what there? No element or member in that set. Full stop, please. Usually, an empty set is represented using a Greek symbol. Usually, an empty set is represented. Usually, an empty set is represented using a Greek symbol. Greek now, Greek, using a Greek symbol called pi, phi, using a Greek symbol called pi. And this is your pi, yeah? Greek symbol called pi. An empty set is simply a set that contains no elements, right? And the symbol for representing empty set is called what there? Is called pi. And what is the symbol? This symbol for what? Pi. Or an empty curly bracket. Or an empty curly bracket. You see these two symbols. Either I use this one or I use this. These two are used to represent what there. That set is an empty set. If I give a set A to be equal to this, what does it mean? It means set A is what? Set A is what? An empty set. That's the concept. No. Yes, yes. Null. And it's called an empty set or null set. You can call it an empty set or null set. Null, null set. See the same thing, please. But you sometimes they want to convince you. They can define null set, right? But they know it's what an empty set. So bear in mind that empty set is also called there a null set. Null, null set. All right, that's number one. I will go, please. I will go, please. So if I have example, if I have given a set A to be equal to this, or I have given a set B to be equal to this, it means set A is what? An empty set. Similarly, set B2 is what there? An empty set. Number two, please. Number two, please. Let's look at single tune set, please. Single tune set. Single tune set. But as the name implies, single, right? It means it has what? Just one element. So this is a set that contains one element. This is a set that contains one element. This is a set that contains one element. How about this? So any element that contain one any set that has one element in it is called what there a single tune. What do I mean? If I have set B to be equal to, let's say, alpha, for instance. How many member is here? One member. So set B can be called what there a single tune set. This is a Greek symbol called what there alpha. If we go back to your previous SS1 where you do inexpressivity, alpha, beta, and gamma, right? So that's like Greek symbol. So like this one, the way this one was Greek symbol, this one is Greek symbol. So by the way, the element says how many here? Just one. It's called what there? A single tune set. By the way, question please. If I have a set Q to be equal to, observe please, this, and I have this. What is it called? What do I call this? What do I call this one? Empty? Listen, I said if I have a set Q to be equal to this, what do I call this? Is it single tune or an empty set? Why single tune? Why empty set? Mhm. It shows that there's something inside of it. How many is that thing? Just one. That's what there. A single tune. We said if they are separated, when they are separated, they are what? Single, empty, empty. But if the fact that I was having something inside, that is what? A single tune set. Please observe that stuff, please. Are we ready? Number three, please. Let's look at the concept of finite and non-finite sets. Let's do finite sets and non-finite sets. Are we ready? Okay. Number three. Shall we? Now, in this word here, there are two key concepts here. We have finite and what the non-finite, or you call it finite, whatever English you want to use there. By the way, now listen and listen, please. Listen and listen. There's something you need to observe here as we are doing this particular one here. You know some cases that they'll give you set like this. A to be equal to, let's say, 3, 4, 5, dot, 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 like this, right? And the dot is intentional. It's not 4, it's just 3. Go and check every textbooks. The dot is what? Is 3 that is there, not 4. So it's not more than what? 3. I will go now. You get to know why you have this kind of thing. Yeah. Now, there are two things. Let's explain one by one, please. A finite set, please. Let's define finite set first. A finite set is simply a set that has a restricted number of elements. A finite set is simply a set that has a what there? A restricted numbers of elements. That has a what? Restricted numbers of elements. Stop. How good? I'm not reaching the class. What I'm establishing is what? Understanding. Understand? So we said a finite set is what? A set that what has a restricted numbers of elements, which means hold on. Come again. What I give you from the beginning? I said what there is simply a set, a restricted number of elements, comma, in which all the elements can be counted. You can count them. In which all the elements can be counted. All right. You can count all the elements, please. In which all the elements can be counted. Example, please. Example, please. Let's say I have a set Z to be equal to this, please. Look up. To be equal to, let's say, 2, 3, 4, 5, 6, and 9, for instance. Are we good now? This is my set Z to be equal to this value. This is what? A finite set. Why? Because it has what? A restricted number of elements. That's case one. Number two is what? I can count them. How many is there? 1, 2, 3, 4, 5, 6. It's countable. There's 6 elements here. So an element that you can easily count is member are called there a finite set. And we good, please. Understanding? Number two, please. Let's continue, please. Let's look at non-finite set, please. Non-finite set. Let's explain non-finite set or non-finite set, whichever one there. A non-finite set is simply a set whose number of elements cannot be counted. Right? A a non-finite set is simply a set whose number of elements cannot be counted. Comma. Whose numbers of elements cannot be counted. How good? It does not contain a restricted element. It does not contain what? A restricted element. Full stop. It does not contain a restricted element. How would this? So it's clear. The English is clear. Now, for non-finite set, said it's a set that all the members cannot be what? Counted. For instance, I give you this dot means what? It continues. Now, hold on. Example. Let's say I have set Q to be equal to, let's do the same thing here. 2, 4, 5, and dot dot dot. How good now? So this is what a sample, the way a non-finite set comes. So if you see this kind of writing, this is what a non-finite set. Why? Because what? The dot. Now note something, please note. For a non-finite set, please note. For a non-finite set, 3 dots are used to show that they continue. For a non-finite set, 3 dots, this one here, 3 dots are used to show that that particular set continues. 3 dots are used to show that they what there? They continue. Are we good? 3 dots are used to show that they continue. Stop. So by now you should know the difference between what there a finite set and what there a non-finite set. One, you can count the number of elements inside it. What's the other? You cannot count them. They are what? Infinity. If I ask you, what's the okay, yeah, great question. If anyone that give me value, anybody in this class that give me answer to these questions, I'm giving you transfer of 5k. Now, 5,000 naira, right? Already? Already? What is the last number of an even number? What is the last number of an even number? That's all. 5k, your account. What is the last number of an even number? Of course, to have a last number, a value. You're free. 5k, 8 Abby. Said 8, okay. Said 8 is the last number of an even number. So what is the last number of an even number? Alright, assignment to everybody. 2 is the last number of an even number. Okay? 3 billion is what? 3 trillion is what? 3 quadrillion is what? So what is the last number of an even number? 2. Okay. Wait again. Now, assignment to those in class and those online. Leave your answer in the comment section. What is the last number of an even number? Assignment. This next class, I want my answer. Don't use ChatGPT. Okay. All right. Let's proceed, please. That's by the way. I won't say the answer, but make research, please. Are you giving me answer? No. Make research yourself. Number 4 now. Number 4, please. Number 4. Let's look at the fourth type called subset and superset. Subset and what there? And superset. All right. In this stuff, there are two things here, right? But if I explain one, the other will reveal itself. How good now? Let's look at types of subset and what there and superset. Type of what? Subset and superset. Shall we? All right. First things first. Listen. The way we explain this stuff for you is this. Look up this. Look up this. Look up. Look up. For subsets and supersets, you can understand them by comparing two given sets together. Probably set A and set B. Set A has its own children, that's elements, its own member, and set B has its own what? Member too. So compare the two, you can now understand what we mean by what? Subset and what the supersets. Now, given a set A and B, put down please. Copy down please. Given a set A and B, given a set A and B. Samad, is it recording? Alright, thank you. Please, my mic, always check if the light is on. So it's not going to get off. And I will shouting, and then nothing is recording. Given a what? Given a set A and B, such that all the elements in B, listen up, such that what? All the elements in B can be found in A. Given a set what? A and B, such that all the elements in B can be found, or use the word are contained in B. So such that all the elements can be what? Found in B. Given a set A and B, such that all the elements in B are what? Are contained in A, or can be found in A. How good? How good this? Given a set A and B, such that what? All the elements in B can be found in A. Hence, B becomes the subset of A. Hence, B becomes the subset of A. On the board, please. This symbol. Hence, B becomes, write that thing out. B becomes the subset of A. Those A and B should be in capital letter because they are your sets. I can see the way I'm writing them. It's not small letter, it's capital letter. All right. So I said, hence, B is what? The subset of A. Written has, on the board, please. Written has this, please. How good? Why by logical extension? Why by logical extension, A is the superset of what? Of B. Why by logical extension, A is what the superset of B, as shown on the board, or written as on the board, please. How good, please? How good? So let's explain this example. Can I come again? All right. Now listen, look up, please. Given a set A and B, let's say given a set A, observe please. Given a set A and a set B. How good? So let's say this 2, 3, 4, for instance. And here is 2, 3, 4, 5, 6, right? I said given a set A and B, as in this case, such that all the elements all the elements in B, 2, 3, 4, can be found in A, 2, 3, 4, automatically it means what? B is what? The subset of A. Subset is it's hide under something. So B now can stand alone because A is the boss here. A has all the skills, but B possesses these three skills alone. So it means that he has to follow this A because A is like the boss. So that if A see opportunity under this, he can what give B the offer, and then he can go with what other three offers that B does not know about. So in a case whereby all the elements in one thing can find another one, it means that that thing becomes what there is subset. Becomes what subset. So in another way, it means that this A is now is what superset. Do you get it now? So I'm saying that given a set A and B, such that all the elements in this B can be found in A, it means that what B is a what subset. And now check the arrow for subset. Subset is left. How good now? Superset is what is right. This one is called union. This one is called intersect. How we get there? This is like a game pad. That means got a game pad to play. So they have meaning. This is what subset. This is what superset. This is what union. This is what intersection. How we get there? We'll explain. Now that's how you define superset and what there and subset. How good? Number 5, please. Number 5. Number 5. All right. Number 5. Let's look at the concept of power set. Let's do power set. Power set. All right. Or the power set. As a Nigerian, I'll call it power set. You know, for others, I'll call it power set. I would. So let me call it power set. So you must blend. Let's call power set. A power set. Mini past tense. So I didn't say past tense. So okay, a power set. A power set. Let me use my mouth and call it power. A power. Okay, number what there? Number 5, Abby. Let's look at the power set. All right. A power set is simply a set. Hold on. For power sets, hold on, please. Given a set A, given a set A, please, that A is not a capital letter. Huh? Capital letter. All right. Not capital letter. Capital letter. Please. All right. Given what the not power, it's called what power set. I said what the given a set A, the power set of A, the power set of A is written as the power set of A is written as this, please, on the board. The power set of A is written as this one here on the board. P to the power of A equal to 2 to the power n. How good? Yeah, because it's set A. So set A is always what? In capital letter. That's why I have what the capital letter there. That's in Q out there. Now this P means power. This A means that set A. So the power set of A is equal to what there? 2 to the power n. This 2 to the power n is constant. It's always there. So as I'm writing P to the power Q, always attach what? Equal to what the 2 to the power n. That's like a formula to solving it. And what does n means? N means number of elements. N means what there? Number. Let's write it down. Numbers of what? Elements or member, right? Alright. In that element or in that surface. Number of elements in that set considered. In that set considered. Of course, it was in this case what? It was A considered here, please. So listen and listen. Given a set A, the power set of A is what here? Is this a B? And I said this n means what there? Number of elements in that set. In this case, what I set here? Set A that I put A here. Now, what is the meaning of power set? It tells you, continue please. It tells you It tells you the total number. Hold on. It tells you the number of subsets. Power set tells you what? The number of what? Subsets that can be got from a given set. It tells you what the total number of what? Subset, or it tells you the subset that can be what? Got from what? From a given set. Full stop. Full stop, please. It tells you number of what? Subsets that can be got. That can be got from what? From a given set. Engineer, one touch. Shall we? You understand? You understand? Shall we? Are you at the back, shall we? Behind the scene. Alright. So now listen, that's by the way. Now when we say power set, we said what? It tells you what? The number of what? Subset I can get from what? A given set. That's the function. But whichever way, the first step is what? You have to what? Write out this expression first. So for this one, look up. For A now. This is A now. A. This one work with it, Abi? Yes. Now what will be N? If I consider this question as my A, what will be N? Yeah. What's N? What's N mean? What's N? How many elements is there? One, two, three, four, five. Five elements here. What will be here? Five. Right? Example, please. Example. Example. Write out the power set and also list out the subsets. Write out what? The power set and also what there? List out the subsets. Write out what? The power set and also what there? List out the subsets from the given question below. From the given question below. You have them here. Okay, shall we? So first things first, question 1 says A to be equal to, alright, I have what? An empty set. Question 2, B is equal to what there? Let me use let me just use 2, a single tune set. Question 3 says I have set C to be equal to, let's say let me use 3 and 4, 2 elements. Question 4 say let's use D to be equal to, let's say 3 elements here. Let me use alpha, beta, and gamma. Alright. So we're having this list. This for examples. Let's take them and move on, please. Let's take this for examples and move on. Shall we? Alright. Solution. Alright. So I want to. I'm taught what. Write out the what, the class terms. Also what the list out the subsets. The issue here is listing out subsets. It's difficult to list out subsets, but I'll take my time to explain them. I bet the two. If I do number 1, you understand. Number 2, you don't get it right. Number 3, start getting clear. Number 4, you now understand it very well. So I give you from 0 to 1 to 2 and 3 elements. Are you ready? What's number 1, please? It says what? Given set it what? An empty set, Abi. So we said what? For we are taught to write what? Write out what? The power set and also what? List out what there. So like for each question you having what? For each question you having what there? 2 answers, Abi. What's the person there? Past, Abi. So the power set of what? Of A now is what? 2 to power what? N, Abi. And N is what in this case? N is what? N is 0 now, Abi. That gives you the power set of A is what? 2 to power what? 2 to power 0. And that's what? And that's 1. Anything to power 0 is what, please? Huh? Is what? Huh? Anything this power zero is what? Huh? X power one is what? X power one is what? X power zero is what? X power one is what? Well, I say what? Anything this power zero is what? Is one. X power one is what? Uh-huh. Ah! Oh, two. Please, anything x power zero is one. Oh. But anything x power one is that thing back. Any fucking thing. Buhari x power zero is what? Is one. Tinubu x power one is what? Is Tinubu. Please don't come and catch me, I beg you. So anything x power zero is what? Is one. X power one is what? That thing. This thing, I've explained it to this young man. Oh. But anyways, keep learning. Copy this down somewhere. I don't know. Just have it there. Never in your life forget again. Forget shoot yourself knife because it will be painful. It's easy, please. It's easy, please. Now kill yourself. Oh. All right, shall we? So S per zero is what? S per one is what? That thing. Don't give me English. That thing. S per zero is what? S per one is what? That thing. The given. All right. So it means that the first of A is what? Is just what? Is just one. Abi? So I'm done with it, please. So what's the second question? List out what? The subset. Listen, oh, write out the power set. I'm done. And also what? List out the subset. Now, by the way, this power set I are seeing here. What's the power set? What's the function? It tells you the total number of what subsets that can be got in a given set. So for subsets, observe please, oh, for subsets, your first task don't even always start with what? An empty curly bracket or a pi. So for if you want to look at power set subset, start with what? An empty bracket. Now, engineer, I can hear you. How dimension? Yeah, give me that dimension that is coming. If you use what I said, when it comes to subset, your first thing to do is what? Always write out an empty curly bracket first, or a pi. So the text is what? Always write what? An empty set first. So I want to list out subsets. What's my first thing? First thing is your first thing to do what? Write out what? Either use this symbol or that symbol. So this is my first one. One. I want to list out subsets. Abi, your first time is what? Start with what? An empty curly bracket first. After that, you now move on to the next one. But observe, this is how many here? How many is here now? How many is this? How many is here? How much is here? How many is here? One. This is one stuff now. This is one stuff, Abi. That's all. That's all. You get it. Just hold on. I told you that you won't get it in the first one, even the second one. But the third one, you start getting it clear. I'm telling this again. Before you start for subset, always start with what? An empty set first. Either use this symbol or that other one I gave you, that pi, and then comma. But in this case here, I'm having here just one. How many is here? Two. Just one. All right. That's number one. Observe, please. Number two. Just water, please. What's number two? B, Abi. B equal to what? 2, Abi. Now for this 2, let's have a power set of B. So the power set of B, P of B is what? 2 to power what? 2 to power n, Abi. What's n here? N is what? Is 1 now. How many elements is here? N is what? Not that thing. But what? How many elements here? N is 1. So what's p to the power b? P to the power of b is what? 2 to the power what? 1. What's my answer? I just give you now. N to the power 2 is what? Hold on. 2 to the power 1 is what? 2 to the power 0 is what? Are you sure? Hey, is 2. I will go now. What's my answer now? 2. So it means that the part of B is of course what there? Of course 2. I'm done with this man. What's next now? For subset. For subset. What's my first instance? I said first instance start with what? An empty bracket first. So that gives you an empty bracket. Now, comma. What next? Check your question. What's the how many things here? 2 Abby. 2 is the only thing that is element that is here. Write it out. That gives you 2 Abby. Is there an element here? That's so how many is this? 1, 2. How many is here? 2. That's all. Start with an empty set first. What is an empty set? Now check a question. Is there anything? Yeah, when I wrote out to empty set, was there anything here? No, then I left it at this. That's 1, 1. When I wrote out empty set first, and I check my question. This is 2, right? I must have 2 subsets. Now said the rule says what? Start with what? An empty set. Empty set done. Go back to your question. How many elements do you have here? Just 1. What's that? What's the element? 2. Write it out. How many is there now? Aside these 2, is there another element here? No. So how many is there? 1, 2. How many is there? 2. Balance. Hold on. Let's do number 3. What's number 3 there? C, Abby. What's C? I have 3 and 4. What's n here, please? What's n? So p to power c is what? 2 to power n. What's n here? N is what? 2. That gives you 2 to power what there? C. 2 to power what there? 2. What's to power 2? Eh? No, I'm not interested in you. No. I have a calculator. 2 to power 2. Alright. What's to power 2? That's 20, Abby. I don't know why all these young guys now, I've forgotten all these things. Now, man, the pursue. Abby? Oh, yeah, 2 to power 2 is what? 4. How? Explain, please. Prove. Eh? How? How's trying to? Okay. What of 2 to power 3? What of this one? Huh? 9. Okay. 6. Okay. Somebody said here is 9. Somebody said here is what? 6, Abby? Wow. Huh? Now listen. Go back to, let me call it, just so I won't finish you guys up. Go back to this is 1. Oh class. This is 1. Go back to that level. If I have 2 to power 3, this power, or we call it index, or we call it what? Degree. It tells you how many times this thing should occur. 3 Abi, that's what? 2 times 2 times 2. If I have 2 to power 2, 2 to power 2 means what? 2 in what? 2 places. And that's what there? That's 4. What's my answer here? You guys got it, but you are not too sure. Because for you guys to get it, you did 2 times 2. Sometimes I give you, oh yeah, I do this one by someone 2 times 3, 6. How do you even get 9? Who got 9? How do you get 9? Can I prove it? 2 times 3. Nice one. Please observe what I just did now. So this power tells you how many times this thing should occur. Are we good now? So a power or an index or a degree is used to tell how many times that thing that is being raised to should what? Should occur. This is my 5th time. with this young man. Hey, now I think no, announce the class. Sorry. Let's continue. I think we're having tests. Don't worry. I want this test on Wednesday or Thursday, sha. Let's get prepared. That same day, social making test. That same day, math test. That same day, field making test on this one board. So math will be here, social making will be here, and field mechanics. I have just 15 minutes, 5 minutes for each of them, and then are you ready? Yes. No, I'll bomb it. All right. So by now, you have all these things on your head. What's field mechanics? Problem. Problem. Define force. What's force? Dead. What's pressure? Pressure. Okay. Hmm. Ah. Eh? What's density? What density? Eh. To use the test. Wisdom. All right. This is how you solve for per set and a subset. I'll go, please. Let's do an example, please. Let's do an example, please. Oh, thank you very much. So we have gotten what our pastor B. So the pastor of C is what? Is what is just 4, right? We want to list out what subset. What the person I say you should do? What does it I should do? Your what? Empty bracket first. 1. What is it now? Go back to your question. What the person you have seen here? What I seen here first? 3. Write out 3. 3. What's next again? 4. Write out 4. Now, listen. I started with what? An empty. After empty, pick them one by one. After one, what's next? Pick them what? 2, 2. So if I put it all over here, exactly, that's what? 3, 4. 2, 2. Is there nothing aside 2, 2 here? That's how many is here? 1, 2, 3, 4. What's here? 4. That's all. Put them in empty sets first. Put them in 1. Once, 1. Put them in 2. Put them in 3. 4. Look like it happens. Now let's number 4. You understand it very well. I'll go now. So to power 4 now means it must be in 4 stuffs here. Start with an empty set first. Then pick those questions in 1 by 1. That's 3, 4. And put them in what? In 2s. Write them together. After 3 and 4, is there another thing there? No. You say 4 and 3. 3 and 4 and 3 are the same thing. I'll go, please. All right. Shall we? Let's do number 4 and see what will happen. Hope you are done writing something here. I'm done here. First, please. Okay, I can do that way. Okay. Let's explain question 4 and see what we get. Please, is it recording? All right. Please, tonight or tomorrow morning, I expect the video in the group, right? So in case I've forgotten what I said here, you can check back, for the video online, then you have it, with you personally. So look up, please. Let's do question. Hey, sorry, I've cleaned it up, please. What's question 4, please? Question 4. Is that not D? D equal to what? Alpha, right? Alpha, beta, and what? And gamma. All right. Please, first things first. How many is here, please? 3, right? So the p to power D, p to power what there? N. What's N here, please? What's N? N is what there? 3. Short form. N is what there? 3. How good now? Get what I'm saying? Now, if I put this, gives you what? P to power of what? D equal to what there? P to power 3, right? What's power 3? 6, Abby? 6, Abby? Yeah, 6, Abby?
Yes.
Eh?
Yes. 2 times 2 times 6.
Is what? Is 6, Abby? 2 times 2.
6
times 2. 6, Abby? 6, Abby?
Yes.
Please. It's 8 now. 2 to power 3 is of course what there? 2 times 2 times 2. Sorry. 2 times 2, 4. 4 times this 2, 6, Abi. Eh? 2 times 2, 4 times 2. How this is? Is that what is it that we wrote there now? I told you it's 8 that we wrote there now. Because so you guys gave me 9, and you gave me 6 and 9. He gave me 9, he gave me 6. And I tried to explain it. I wrote it here boldly. That is what? 2 times 2 times 2. 2 times 2. 4. That's 2. That last 2 over there. 8 now. Hajiko? Like calculus what? One is what there? 8. So it means P to power D is what there? Is 8. So I'm looking at what? 8 subset. Crazy. What's the first one, please? What's the first one? Empty, Abby. What's next one? Alpha, Abby. Alpha. Okay. What's next one? Beta. Okay. What's next one? Gamma. Put them in one by one, Abby. What's next now? Put them in twos, Abby. That's alpha, beta, alpha, gamma, beta, gamma. Abby? That gives you what? Alpha, beta. Look up. Alpha, beta, alpha, gamma, beta, gamma. I'm going forward. Alpha, beta. I have alpha, beta. What's next now? Alpha, gamma. That gives you alpha and gamma. What next there? Beta, gamma. I will go to this. That gives you, we're not repeating anything. That gives you what there? Beta, gamma. I am done with this in them out in how many? In twos, Abi. What next now? Leave them in threes. What's 3 here? 1, 2, 3. That's all the 3 there. Nothing else again. That gives you what there? Alpha, beta, and gamma. How many is there, please? 1, 2, 3, 4, 5, 6, 7, 8. What's there? Clap for me, please. Clap for me. Clap for me. Thank you. Thank you. Thank you. Okay. Anyway, so this is how you list out your subsets from a given set, please. Understood? Copy down and let's proceed. Oh, man. Yeah. Okay, thank you. Okay. Yeah, okay, sorry. Share beer. So, all right, guys. So, if you are also interested in learning about digital skill, right? You want to learn how to create several videos using AI, right? You want to move into the space of using AI to create images, to create avatar videos, not avatar cartoon video. I mean, you can create yourself talking using AI, right? And also, if you want to learn about how to market or how to make sales or how to create a course for yourself or for a business, you can reach me out. So I'm also in for that job, right? So feel free to reach out to me on my DM. See my WhatsApp number on the screen. Reach me out there. Let's move on to other types of sets. So we'll do universal set. We'll do union of a set, intention of set, um, difference between sets. Wow, we still have a lot of things to cover, please. A lot of things to cover. But what now? Type Abi, six Abi. Are you sure? The test number 6. Okay, number 6, please. What am I cleaning, please? Yeah, Abi. This place here. All right. Number 6, Abi. Let's look at the concept of complement of a set. Complement of a set. Complement of a set. Number what? 6, right? Let's do complement Complement of a set. Alright. Complement of a set. Given a set A, okay, so write in complement of a set. Complement of a set. Complement of a set, please. Shall we? Given a set A, given a set A, the complement of A is written as A to the power of C, or use the word A prime. That's the two symbols. So if I see this means what? Complement of what? Of set A. Also with this, please. How good? What's the function? Complement is C now, like of set A. So this means complement of what? Of set A. What's the meaning? It tells you the total element in that set, or it gives you the total elements or the total element in that set. It gives you the what? The total or total element in that set. Shall we? So what does it mean? If I have set Q to be equal to, let's say I have 0, 1, 2, 6, 11, and 13, for instance, as my set. So it means that the complement of set Q is what? 1, 2, 3, 4, 5, 6. That's 6. That's all. It tells you how many elements you have in that set. That's all. Number 7, please. Number 7. Okay, type number 7. Type 7, please. Let's look at. How good? Number what? Number 7. Let's look at difference of two sets. Difference of two sets. Difference of two sets. Of what? Of two sets. How good? Given a set A and B, given a set A and B, their difference is written in two forms: A minus B or B minus A. Alright. I said given a set A and B, given a set A and B, their difference is written in two forms. Of course, on the board, written in what? In two forms. Please, is the video clear enough? So, I said given a set A and B, their difference is what there. What and what? This, please. Um, given as what? This and this, right? Now, what does it mean? What does it mean? What does it mean? A minus B means what? All the elements in A can be found in B. This one means what? All the elements in B can be found in A. That's the meaning, please. So don't forget, please. We have A minus B. It simply means that all the elements in A are contained in B. So this superset and subset are more like the same ideas, right? So that one is equal set. It means the elements in A and B are basically the same thing. So there's no called equal set. I don't have to teach you that one. Equal set, by the word equal, they are the same thing. If A is having 1 to 5, B is also having what there? 1 to 5. So they're the same thing. That's equal set. That's by the way. So for difference with set, we're having two ways form: A minus B, or what there? B minus A. A minus B means what there? All the elements in B. Exactly. What this one means what there? Elements in B can be found in what? In A. Number 7. Sorry. Sorry. Number 7. Yeah. Number 8, please. Universal set. universal set. Universal set. This is a set of all possible elements. This is a set of all possible what the elements. This is a set of all possible elements. It is represented using the symbol is what represented using symbol. Look up please. This you see this when you draw your when you look at Venn diagram, you will see something like this. This one here. See this what universal set is a set of what all possible elements. So for instance, listen. As we have president, right? We have our mother and father, right? They are under what the president. So president is more of like the universal set, the superior, in which everybody is what under him. So it means set A and B, all the elements in set A and B can must be found in what universal set. Why? Because it is a set of what all possible elements. It must be there and it should be there. That's the concept. How good place. That's nothing else to do here. Number 7. Number 9 please. Number 9. Number 9. Number 9. How good please. Let's look at union of a set please. Union of a set. Alright. Union of a set please. Now that I didn't take anything, I'm giving you this thing on my head. So you should be able to do that too. Right? You should know the steps. Okay, look. As I'm teaching you, I have a particular note with me. That note, as I'm teaching you, I'm seeing the page on my front. It shows it clearly. If I open like this, I know what to see. So as I'm opening, I see what I'm seeing. I'm in that space entirely. All right. So when you get a level, you read book. You'll be seeing all the book in your face like this. If you if I open this like this, okay, that's what I'm seeing there. You'll be seeing it really like the realm, the level. Let's get it first. All right. Union of a set list. Union of a set. The union of a set. The union of a set is a combination of all the elements in a particular set without repetition. This is a combination of what? Two or more sets together. Union set is simply the combination of two or more sets together. By the word union, we want to make them like the word United States. They are unite. They are becoming one. You understand? By the word union, it means set A and B, regardless who is boss or not, they must what there? They must combine together. Right? That's the concept. So it means I'm saying that union of a set simply means the combination of what set A and B without what there repetition. I will please. The symbol is this place. This union, the symbol is this place. The symbol is this place. This union place. How good? Now, what is it? They are different though. By the way, you can like this. It's okay like this. Just is a curve like this. This is look up. This is what superset. This is what subset. This is what union. All right. What's left now? Intercept. Let's intercept now. All right. I said so. This is union of itself. Is understand. This is your U. You is having now. Your U will have this thing now. Abi. All right. That's you. It's clear. This parabolic curve. How good please. Let me explain what I mean by this concept, please. Look up. If I have set A to be equal to, observe please, 2, 3, 4, 6, and 10, and I have set B to be equal to 1, 5, 6, sorry, 5, 7, 6, 8, and 9. And I ask you for, please, what's the value for A union B? What's my answer? We said union means the combination of A and B without repetition. So list out all the elements in A and B, and by the way, it must be in order of what? Arrangement. Don't carry 6 first for 1. So yeah, what will be there? What's the person I write here? 1, 2, 3, 4, 5. Observe, 6 is how many times? 2, but what? We don't want repetition. Write it once. That's 6. What next there? 7. What next? 8. What next? 9 and 10. So I have listed out all the elements in A and B without what? Repeating this 6 and 6 here. So that's the idea. Without what there? Repetition. I will go please. I will go please. Copy down please. Let's proceed. Let's look at the 10th one called the intercept of a set. This will be 1 hour plus. So I'll talking to. Let's do what there. What's next in there? Intercept, right? Intercept of a set. Number 10 in right? Intercept of a set. How good? Given a set A and B, given a set A and B, given a set A and B, their intercept is written as A intersection B. Alright. Given a set A and B, their intercept is what? Written as A intersection B. How would this? It tells you the element, it tells you, given a set A and B, given a set A and B, how good? Given a what? Set A and B, their intersection is written as this. Their intersection is written as this. How good? It tells you the elements that are common in both set A and B. It tells you what there? The elements that are what? That are common in both what? In both set A and set B. Alright. How good? So for instance, if I have, let me send it. No, I won't send that. No, thank you very much. Shall we please? Now look at this. So intercept means what? So let's say I have these same examples. This same example. No, I can't use this one. You understand? So okay, let me use this one. Let me use this way. Look up please. If I have A and B, but this, so write the same thing outside here. But I'm asked to find A intersection B. What does it mean? It means what? Listen, the elements that are common in the two of them. So which element is common here? 6 is here, is here. They are common. So what's the element that's common here? 6. So what's my answer here? 6. That's all. Intersection gives you the elements that are common in both what? Set A and what there? And set B. That's all. Alright guys. We have come to an end for the batch one to this questions. So sorry, to this set. The batch two in the next class is on set theorem. You have a question? These are what you know how to do now. I don't have any issue with this one here. The question one says, um, question one says, let's see, question one, they gave you, that's another set, they gave you set A and B and C, but they give you in what form is this? Eh? No, 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 I'm not saying that. What form is this? They give you set A, B, and C, and another set in what type of form? Number one, they gave you universal set, Abi, A and B. What kind of form is that? What kind of representation is that? That's what by that's what I'm asking you. This is what by set readers what notation way. So you have to what write it out in what form? In by listing first and what you now solve them. How good? So let's solve this in the next class, please. When I finish assignment, so tomorrow this person will do tomorrow, and I'll do the rest at the same time. How good? All right. My answer, please. So send it to me on WhatsApp. This is 1 hour 30 minutes. That's